So first of all, do you have any questions for me over the most recent stuff?
I have a question about like school.
Yes.
Do we have school? Are we gonna have class on Thursday? I'm really confused about that.
Yes, in fact, I was anticipating that question. I
I,
got it a couple times yesterday. So, this is the one time that we're not following the calendar that was established. So, this was the calendar that was approved last year, back when everybody was sure we would be back in session normally now. Let me change it so I can draw on it. Normally, tomorrow and Thursday and Friday would be fall break for you. But Granite School District, this isn't even a names thing. Granite School District decided that we are going to still have school here. And when I was discussing it with one of the students yesterday, my guess is it's because for the online students, they already were missing out on all of these instructional days. And so they didn't feel guilty, is my guess, about putting 2 days back into the calendar when so many instructional days are missing. I don't know. The teachers are about as sad as you are about this. We could use that time, I know, for getting grades and getting a bunch of work done. But, yes, they're basically, fall break has been canceled this year. So, apologies to you. We are going to, on Thursday, do your skills test for this class. And that's really all we're going to do. And remember, everybody's going to get an A on it. The earlier you get the A, the less you have to do. If you get anything below an A, I'm going to make you keep retaking it until you get an A. And it all goes on second quarter. So study what we're doing right now, because there's potential your class could be like 10-15 minutes long is all on Thursday. You do have homework with me today, but you will not have any homework with me on Thursday. So at least that's a little bit of a gift to you for the weekend. So,
will we be able to use our notes for this test or
nope,
no?
no notes. I
Are
mean,
we gonna have like a study guide or no?
yes, I haven't put it together. I need to send it out to you after class. I didn't get it last night. But yeah, I do have one for you.
Is it gonna be like that cool website where it's like you can redo it again and again, or is it gonna be Canvas?
Actually, I'm thinking written, and you're gonna submit pictures to me.
Oh man. Okay, thanks.
Yeah. And you're not gonna simplify anything. Like today's examples, I'm planning on simplifying for you, at least some of them. But I don't want you to simplify on the skills test, because you're actually more likely to make a mistake while simplifying than you are while doing the calculus. More likely to make a mistake with the algebra. Okay, so now that we have started out our Tuesday sufficiently bumping everybody out, like all of you have identical expressions to each other, and they're all kind of, which I don't disagree with. I mean, I was looking forward to fall break too. Not like I could go anywhere with COVID, but it's always nice to have that little bit of a break. But we're going to do what we're told on this one. But like I said, I'll keep it pretty light and easy for you. You will have the skills test, but it's basically just show me in class what you know. We'll work with it, and then pass it as quickly as you can, certainly, but because we're not putting on, or because I'm putting on second quarter, we have some time to play with it. All right, chain rule. Get your notes out if they're not out already. What we're going to do today is I just have pages of examples for you. We're definitely not going to hit all of them. There's no way we'll hit all of them in the time being. So one thing I want to know from you, though, is how much do you want me to focus on simplifying? So again, for your skills test, please do not simplify. In fact, I'm not even going to have the simplified version of the answer written out on my answer key. It'll just be the straight up derivative. But after the skills test, you will need to know how to simplify. So, I want you to put your hand on your head if you want me to show you simplifying, And I want you to put your finger on your nose if you don't. Which is more important to you? Alright, I'm seeing a couple more hands on head. Now that's not to say I'm going to simplify all of them, certainly. But I am going to at least show you that process and maybe help you do some of the more difficult algebraic ones. Just to show you what's coming. And how to get used to that. Okay, so far, you can take the derivative of things that look like this. But not when we modify them ever so slightly. Today's rule is just going to address what happens when we add another layer to our example. And what we have here with chain rule is they're all going to be something called a composite function. And composite functions, remember, are when you could break down your equation to maybe look something like this. So for the first example, I could say that the outside function is what I see right here. So in other words, let's write down which function I'm using for y equals square root of x squared plus 1. I would say that the f function would be that outside function. And my inside function is what I see inside the square root. Does that make sense? Is that familiar enough? Because the rest of the lesson will depend on understanding how I broke that down. One of the great things about the chain function, and it's called the chain function because you can add as many links to the chain as you want. Technically, I could have f of g of h of z of x. And this rule will still tell me how to break down the derivative, no matter how much stuff I try to stuff into other stuff. It's kind of like, it's holiday season, it's like turducken. Are you familiar with what turducken is? Both Aurora and Emily gave me awesome faces on that one. Andrea, would you explain turducken?
I forget which order it is, but
I think turkey's the big one.
Yeah, and like a chicken's in a duck, and then the duck is in the turkey.
Yeah. So I have never had it. It's just like a meat fiesta of sorts, though. But you take the turducken. You take the chicken, and you put it inside duck. And it's all wrapped up in duck. And then you take the duck, and you put it inside a turkey. And then you cook it all, and then when you cut it open, you've got these 3 different meats together. It's one inside the other, inside the other. So that's kind of like what a composite function is here. Is we have one inside the other, inside the other. We just have to know how to separate it. Because knowing how to separate it is going to be how we get through the chain rule. So, what is the chain rule? Simply put, when you take the derivative of a composite function, and the worst thing about this is watch how many parentheses you have. It's not the end of the world, but it's helpful for you if you have the right number. When you take the derivative, you're going to take the derivative of the outside function and leave the inside function alone. And then you're going to multiply that by the derivative of the inside function. And if you have more links to the chain, just means you add in what you need to add in to your derivative. So in this case, I've got a function inside a function inside a function. I've got a turducken function. I take the derivative of the outside, I leave the inside alone. I take the derivative of the next layer. I leave its inside alone. And I keep going until I run out of layers. And of course, like I said, I'm going to do as many examples as we need for today. It's not that this rule is super complicated, but it does take a little bit more getting used to, I think, than the product rule and the quotient rule. Now, here's what it's not. Somebody's here. Oh, sorry, I didn't mean to scroll it that far. What does not work? When you take the derivative of a composite function, it does not equal the derivative of the outside with the derivative of the inside right there. Okay? So I'm just putting that down because that's the most common mistake I see on these sort of problems. Alright, and Trisha, welcome. If you can put on your camera, that'd be great. We are into the lesson, but don't worry, I am recording this, especially since so many people are missing today. Okay, so, and along with this, we didn't just make this rule up. This can be proven with the limit definition. I'm not going to do it here in class, but you can look up the proof on page 131 of your textbook. Trisha, yes. Oh, and Aurora, I just saw your comment from earlier. I agree. It is foul. By the way, Trisha, Aurora, I have to say, so far, like, your discussion questions, everybody can see them because it's available for everybody. But check out Aurora's because I like all of the definitions you've given me, certainly. But Aurora, yours are my favorite. I was in a robotics meeting earlier this week, and I had my grading pulled up on the screen, and I happened to be on yours, and I hadn't read it yet, and I'm going through the meeting, and then I look over at my other screen, and I read it, just like the first line, and I bust out laughing. Everybody's like, what's going on? And I was like, oh, calculus. It's just calculus. All right. So let's show you how this works. I'm going to do a bunch of these examples for you to begin with, and then slowly send these off your direction. So, first example. You want to break down what function is inside what other function. And so, on a function like this, I can see x plus 1 is inside 1 over x. And of course, yeah, it might get confusing to have so many x's, but the whole idea is when you have f of g of x. Oh, put that in the wrong order. My f of g of x will be the outside function, is determined by whatever's on the outside here. And then wherever my x was on that thing, I plug in my g function. You want to recognize those. I'm not going to write all of them out like that. But you want to recognize what's on the inside, what's on the outside. There's a couple ways we could do this one. I could use the quotient rule on it, certainly. But because I don't have an x upstairs, I'm actually going to choose to use the power rule on this one. So I'm going to come back here, I could rewrite my function. So it's written as a power instead of showing any fractions. Alright. Does this step upset any of you? Are you guys okay with the whole idea of 1 over blah 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 is the same thing as blah 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 to the negative first power? Okay, so when it comes time to take the derivative, my power rule still applies. I bring my number from the power out in front. I rewrite what's on the inside, but here's the important part. I do not try to take its derivative. I just rewrite it. And then I finish with the power rule. It says I have to subtract 1 from the exponent. So -1 minus 1 is -2. And then I come back, and I know this isn't the right one, but I take the derivative of what's on the inside. And so I take the derivative now of that piece on the inside. And conveniently, it's just 1. I'm going to put a box around this because, truthfully, this is how I want it to look on the skills test. Don't go past that. Don't do anything past that for the skills test. You're actually going to make more work for me, and I'm going to grade slower, and you'll get out of class slower if you give me more than that, because I'm going to have that written down on my notes for the skills test. But, of course, when we simplify after the skills test, then I want you to go back through and say, okay, this is in the numerator. -1 times 1 is -1. This has a -2 power, so it's in the denominator. So it would look like that simplified. Which, again, do not give me simplified on the skills test. That one's not so hard to simplify. We'll have some later that'll be a little more work. Okay, so far, how do you feel about the chain rule? One problem
Wait, I
in.
have a sorry.
What'd you say?
One question.
Uh-huh.
Wait, how do you know when to use the chain rule?
It's one that you look at it and you first want to see, is this a rule that is just basic that would fall into something else? I could have, like I said, I could have used the quotient rule on that and avoided the chain rule entirely and just done ho d hi minus hi d ho over ho ho. It would have been completely legitimate. You would have gotten a different looking answer here, which is where, for me, I will have to have both on my my answer sheet. But they both would simplify to the same thing, ultimately. That one, really, you have 2 rules you could pick from. Some of these I'm going to give you, like the next one, there's no doubt. You have to use the chain rule on this next one. Really, it's just going to be kind of, you're looking for, can I break it up into composite functions? What are the things that make it up? And like I said, that one you could have chosen not to do that. Perfectly legitimate. But this one, there is no way around the chain rule on this one. As simple as it is. Nalina.
Sorry, why is your answer have times -1?
Yeah.
I mean times 1, my bad.
Because, let's see, yeah, this part right here was all the derivative of the outside of the function. And remember, this piece right here, that's my g of x. Where my, let's do it like this. This was my f of x. So my rule says I have to take the derivative of my g of x, and the derivative of x plus 1 is just 1. So if I take the derivative over here of x plus 1, I see that it's got the first power there. I bring that power down. I subtract 1 from the power. Remember, your constants go away. And anything to the 0 power is 1. So I just get 1 out of that.
Oh.
Uh-huh. No, good
I
question.
lost track there.
Because a lot of times we feel like it's redundant to put 1s. And to especially, well, multiply by 1. But I am going to still include that here so that we can have, so we can see our different derivatives at play. Good question. Very, very good. Now I can see Trisha, but Emily disappeared. Alright, so on this next problem, there's no way around it. So sometimes you can pick which rule you want, truthfully, and you just make a judgment call. But on this one, there's no way around it. When I learned the derivative of sine, it was for only sine. There was no derivative of sine of anything else. besides just sine of x. So, identify your outside function and identify your inside function. Whether or not you choose to write them for yourself is up to you. What we're going to do is we're going to take the derivative of the outside first. And do you remember what the derivative of sine was? It's been a couple days, I know.
Cosec.
Say it louder.
Cosec.
It was cosine. And you have to leave the inside intact. You cannot touch it. So we have the cosine of 2x, and now, so that's the derivative of the outside. Now we have to take the derivative of the inside. What's the derivative of 2x? Saw two people with their fingers show me. And of course, for the skills test, leave it there. For real life, not much to simplify, but keep going. On this next one, let's not even worry yet about the rule I'm going to use. Anytime you see a square root, you're going to want to rewrite that to be able to take the derivative. What should I change this to before I can take the derivative? What should it look like? In other words, what's another way to write a square root?
The power of 1/2.
Mm-hmm. Anytime you see a square root, change it to its power form first, because it's going to make the problem a lot easier. Can you see what's on the inside and what's on the outside of that function? If you can, I want you to go ahead and try to take the derivative. I'll catch up to you.
I'm sorry. What? Oh wait, never mind.
Check yourself against me, and if you didn't get it, go ahead and copy it. If you aren't sure what went wrong, let me know. Send me a question on the chat or just verbally. How'd you do? Thumbs up, thumbs down. All right. Like I said, it's not the worst rule in the world. Just takes a little getting used to. It is different enough. I do like to spend a full day just on this rule. Where quotient and product, I don't mind doing the two of them together. Okay. Go ahead and try another one. This one's kind of similar. So in the simplified one, to answer a question, I have there, when I use the power rule, let's use that one. My power was 1/2. My rule says I have to take that 1/2 minus 1, and when I do that I get minus 1/2, which is where this comes from. The negative, if I have any, I'm just going to use an x here. If I have x to the negative 1/2, then the 1/2, let's take care of the negative first. The negative indicates I'm going to be upside down. I have to take the reciprocal. And then the 1/2 indicates that I have a square root. So what happens is anytime you have a negative 1/2 power, it's a square root, but it's now in the denominator. And so I do have the square root. I changed it back to the square root form. It's not the worst thing in the world, not at all, if you leave it with the power. I just chose to put it back in square root form. Alright, so let me catch up to you now. And I'm just going to leave it there. I'm not going to simplify that one. Alright. How'd you do? Okay, let's do one more similar to that, and then I'm going to move on to what happens when you have more than one rule, or more than two links in your chain, we'll say. Okay. Alright, compare your work. I went ahead and simplified that one, gave you both versions. How was that one for you? Okay. And that one, I could have done that one in this way that I'm going to do next if I wanted. I could do f of g of h of x and add another link to the chain, because I could have kept this and this as separate powers instead of combining them. So if you do that, okay. Where I'm going to show you with these problems that come next what this could look like. Oh, actually, no, hold on. This next one I'm doing multiple rules at once. I'm not doing h of g of x. This is where it's going to get fun. Alright, so there is nothing to say that you can only use either a product rule or a quotient rule or a chain rule. Because there are times where we're going to need more than one of those rules at once. And I promise, these problems coming up are the hardest ones on the skills test. There is nothing that will be more difficult than these. So, for example, something that looks like this. I see here that I do have an outside function. My square root of is still my outside function for the stuff that's inside of it. But there's something else outside even that is being multiplied. What I see here is I'm going to need to use a product rule and a chain rule in the same problem. So let's see, I've already got the f of x down there. So let's say it's like saying that g of x would be just that first x squared. H of x is going to be the square root of x. And hi, we don't like to use I, I'll use j of x is going to be the inside of that function. So in other words, I could say my f of x is my g of x times my h of j of x. Don't let it throw you. It's not going to be much more complicated than what we've done already. We just have to look at what rule applies to all of the pieces. And chain rule only applies to this piece right here. But product rule applies to the whole thing. So product rule is going to be how I start. When I take the derivative of this, I'm going to start with, I've got to remember that first d second plus second d first that we learned last time. So I take my first function, I leave it alone. I take my second function, I'm going to use it in its power form, and I pull the power down, I write the inside intact, I subtract 1 from the power, and then I take the derivative of the inside. And I'm going to change my bracket, or change my parentheses just to a bracket because there's so much going on there. So in other words, right here, d second required the chain rule to be able to take that derivative. And I'm not done yet because I still have plus second d first. So plus second d first. I think even on the study guide, there's only 1 or 2 questions that will use a product rule, quotient rule, and chain rule on the same one. Seeing 2 of the rules, though, together will be pretty common.
Wait, I have a question. Where did the negative 2x come from in the brackets?
Yeah, this one right here. So this right here is the derivative of the outside. I'm going to write it differently than I did before. So it's the derivative of the, in this case, the h of x part. This was the derivative of the inside. And when I say that, I mean derivative of the outside is the derivative of the square root part. Derivative of the inside, the derivative of 1 minus x squared will give me negative 2x. Because the 1 will disappear. The negative stays intact. The 2 comes down in front of the x. And then I subtract 1 from the power, so I get negative 2 times x to the first power. Does that make sense? Okay. Do you want to see the simplified version of this one? I got one emphatic no. I went through, show you my notes, just that problem to simplify it. So my derivative was here. So up here I just wrote out the problem. My derivative is here. The rest of this work was to simplify it. If you wish to simplify it on your own, I'll give you the answer so you can compare. Simplified. I got negative x cubed minus 2x squared plus 1 all over square root of 1 minus x squared. Is that your opinion, Emily, on whether or not to simplify? And like I said, for the skills test, I actually don't want you to simplify. Something even here, right there. I started to simplify a certain way, and then I was like, nah, I don't like that direction, and I took it another direction. Like, even me, as I was simplifying, trying to decide how to simplify it, I still had to make some judgment calls and could have gone in a couple different directions as to what would give me the most simple answer. Alright, now this next one, I'm going to give you a head start, but I promise not a very long one. There we go. Oh, running out of space. Start again over here. Okay, let's see, what's the next one? Okay, 2 rules are required. On your mark, get set, go. Okay. It's my bell to remind me that that's the end of synchronous time. But of course, with your class, as often as I can hold you over, I do prefer that just because there's so much we do have to get through for an AP class. When our Fridays especially are no longer ours. Okay, so with the 1 or with the 3 at the beginning, I'm assuming you mean this one right here. This just means it's a cubed root instead of a square root when you see it really small over the little hook. And so a cubed root turns into a 1/3 power. And then if there's no number there, we assume a square root, which as the power form would go, it'd be a 1/2 power. So you will, at this level, be seeing all sorts of numbers. You might see 5, a 7 there, a 7th root, a 5th root. It's just all about knowing how to change it to the power form, because the power form is really what we're playing with. And of course, here, you don't want to simplify this for the skills test. You're more likely to make mistakes simplifying it. I would want you to leave it looking exactly like this. But after the skills test, in other words, after next week, I would want you to simplify it, and I'll let you practice on your own if you'd like. Do you want me to show you this one simplified? I mean, like, here's the answer. But do you want me to work it out for you? I can't tell if those are subtle nods or if your cameras are shaking. You want me to work it out? I got 1 yes, 1 no. 1 yes is all I need. Okay. So, this one I am going to go ahead. This is for real life. This is simplified. It's another one that takes a little bit of work. So, if I start again from here, I recommend you let the paper do the work. Don't try to do it in your head. I know that everybody feels like math is something you have to do mentally, but at this level, that starts to get to be ridiculous. Do one thing at a time, let the paper guide you in what you do next. So I'm going to keep it super simple. For starters, I just see like I'm multiplying something by 1. I'm going to get rid of the 1. Over here, there's a lot going on. I think I'm going to take care of what's on the inside first, and then I'll multiply this x on the outside. Not that it's awful. That's just my choice. I see I have a fraction here, and I have a 1 or a negative power here, so both indicate to me I need a fraction bar. And they tell me what goes on the bottom. And then this has no negatives or fractions, so it goes on top. Down here, I can multiply my powers together. That's the rule of if you have a power times another power, is 1/3 squared becomes 2/3 power. And we'll put over here how to simplify. Because again, the worst thing about calculus is not the calculus. The calculus is actually relatively easy. The worst part about it is the algebra and trig. And so it's still a good idea to practice with this, because you will be expected to on the AP test. You will be expected to for later problems. Alright, so this first piece, I don't really have anything else to simplify at this moment, so I'm going to leave it. I'm going to go ahead and multiply in this other x, though, here. And I've got fractions inside fractions, and it's just so ugly. So I think what I'm going to do next is I'm going to look for a common denominator in the numerator. How often can you say that? Meaning up here. So my rule says to have a common denominator. The only way that you legally can do that is if you multiply by a special form of the number 1, and we choose that special form of the number 1 based on what the denominator is in the thing we're going to add to it. And it's way more complicated than we normally see special forms of the number 1. And down here. Now I know some people choose when they're doing a problem they're simplifying, they'll not write the extra stuff. They'll only write the parts that they're simplifying. It's not that that is a bad technique, but the problem with that is you're more likely to forget to put something back into your problem. So that's why you see me still writing some of the stuff that I'm not simplifying. I'm going to keep writing it just so I don't accidentally leave it out of the problem later. Alright, let's see. Upstairs, I see that I have the same stuff, just to different powers here. We have a rule that says a to the n times a to the m is the same thing as a to the n plus m. In other words, you can add together your powers here if your bases are the same. My bases are the same. I have x squared plus 4 in both cases. I'm going to add together the 1/3 plus the 2/3, and I get just 1 there. And over here, because I now have the same denominator, I can put them into the same fraction. And then again with this other fraction that I'm dealing with down below. And I'm going to keep simplifying what's on top there. And if I'm going too fast for you, I'm recording this video. I do recommend you go back and you watch it. Because again, yes, 100% you will be expected to do this sort of simplifying later, as early as next week. So next step, I distributed my 3 into the parentheses, since I'm to the first power that's legal. If it was any other power but 1, right here, it wouldn't be allowed. And I'm liking this because it's a concise fraction now over another fraction that secretly is, you gotta put legs on it. And I'm almost done, whether it feels like it or not. Oh wait, hold on. Back up. Let's take care of something else before I do that. I just caught I have an x squared here and an x squared here. So I'm going to go ahead and do 2 steps in one. Since I'm doing this on video form, I don't feel so bad about that. I'm going to go ahead and call that just x squared plus 12. Over the denominator, and then you gotta think about my little sister. Anytime you're dividing a fraction by a fraction, take the second one, flip it. And then multiply straight across with fractions. Here and here, again, same base. You can add the powers together. 2/3 plus 2/3 is 4/3. And that is as simple as the answer gets. Can you see why I don't want you to simplify on your test this week? For those first few that we simplified, no, they weren't bad at all. Not at all. But some of these problems take quite a bit more work. And the more work it takes, the more likely you are to make a mistake. So, again, not that you're not going to simplify. You're going to have to after this week. But I just, this week, I only wanted to make sure you understand how to do the calculus part. The algebra we come back to. So I think it was good to show you one of those long simplifications. Let's show you 2 more, but they're super fast, especially compared to that one. And then we'll be done. And I'll give them both to you at the same time. Now, first of all here, if you do not see parentheses on this cosine 3x squared, do assume that it's the x that's being squared, not the cosine. Give you a head start on those. I'll catch up and then we'll be done for the day. Josie, you still with us? Yep, go ahead and try these derivatives. And as you go, any questions on that?